So the next issue that we run into is, what do we do when we aren't able to efficiently list all of the outcomes of a compound event in a table or in a tree diagram? We obviously don't want to spend time writing out a table that's going to have lots and lots of different combinations, nor do we want to spend our time trying to draw a tree diagram in some organized fashion that's going to have lots and lots of different outcomes. That's where the fundamental counting principle comes into play. The fundamental counting principle says, look, if you have two different random events, and you can use the spinner example that's on the screen right now kind of as your reference point. If you have two different events that you are interested in counting the possible combinations between, it's just a matter of counting them individually and then multiplying them together. So they have an example written here as well if you're interested in using this example. If there are 4 possible sizes for fish tanks and 3 possible sizes, then there are 12 total possible fish tanks. Every size mixed with every shape makes 12 different fish tanks. That logic principle is a principle that you see a lot if you're looking to combine any kind of random phenomenon. There's so many ways that the first thing can happen, there's so many ways that the second thing can happen, so let's just put them together and look at how many total combinations there are. So if we want to use this double spinner example as our reference point, it looks like this first spinner has 5 different sections on it, labeled by the colors. It looks like this second spinner has 10 different sections on it, labeled by the numbers. So for us, I think it's pretty easy to say that there's going to be 50 different possible combinations when spinning the 2 spinners. Now you could imagine writing out 50 of anything is probably going to be annoying and really inefficient. But if you really wanted to, you would just say, okay, red 1, red 2, red 3, red 4, red 5, and then you list, all the way until you got to green 9 and green 10, going all the way around this spinner and all the way around that spinner for each and every possible combination. I don't want to have to do all of that. But where this particular calculation comes into real importance is when we start to answer questions like this. How many of the outcomes are orange followed by an even number? Now, that's going to be considerably less, because I can imagine that and say, oh, my only success here is if I spin an orange right there, and then followed by an even number. So we got 2, 4, 6, 8, and 10 as my even numbers. So I could easily write those out: orange 2, orange 4, orange 6, orange 8, and orange 10. I think it's pretty obvious that it's 5. We're not going to be as interested in that as we are interested in the probability. We just established that there were 50 total combinations. We just established that 5 of them were an orange followed by an even number, which means my probability of an orange, then an even, is going to be 5 out of 50. But again, we don't want to have to rely on our ability to write them out. We want to be able to logic our way through this just by thinking about the actual spinning of the spinners and how all the combinations interact. So how can I get that 5 out of 50 number without actually having to write out all of the different outcomes? Well, that's where each individual spinner comes into play. How many different sections, if I was interested in an orange and an even number, how many different sections on this spinner were orange? That would just be 1 out of 5. If I needed to follow that orange with an even number, how many even numbers were there on here? Well, 2, 4, 6, 8, 10. There's 5 even numbers out of a total of 10. You can see then how we get from these 2 fractions to that fraction. Just like we multiplied the total number of outcomes together, the individual number of outcomes together to get the total number of outcomes, we can do the same thing with the probabilities. We don't have to say, oh, let's try to list them all out. We know going in that this probability was 1/5. one of the sections was orange, and this one was 5/10, 2, 4, 6, 8, 10. So if I can calculate those individually and multiply them together, then I'm able to find my final probability.